Next, we'll work on basic part 3, which is this model over here. In this model, we'll introduce a new concept called slot, which is this portion over here. Yeah, so this is actually a function in the sketch tab. Actually, this image over here is not really sufficient to to fully CAD out the file, because actually there's one missing information, which is this hole over here. This hole is actually not a through hole, means this hole means this hole actually doesn't penetrate through the whole body. It only penetrate through until this surface. So this problem occurs because this image was extracted from some of the past paper, and in the actual exam, when you take the actual exam Tenjix, each question there will be at least 2 images provided. Some of them may even provide 3 or up to like 4 images. Yeah, so multiple images will be provided, and these non-true hole features will be explicitly mentioned. Yeah, because in this case we only extracted 1 image, that's why this information is missing. Yeah, so basically this hole does not penetrate through through the whole thing. Okay, after knowing this, we can start. Create a new part, save it. Then define these variable dimensions 60, 40, and 8. Sixty, 40, and 8. Then we can start by drawing this bottom door-shaped sketch. We can start on the top plane. You can directly use a corner triangle like this, but however, because I personally want to preserve some planes of symmetry, so sometimes you can actually use the center triangle, which is the second option over here. So basically, when sketching a center triangle, you are defining the center point of the triangle. Then after that, the I'm sorry, why did I keep saying triangle? Okay, rectangle. Yeah. So so yeah, if you when you are drawing a corner rectangle, you are fixing you are fixing one of the vertex, in other words, one of the corner of the rectangle. Then after that, extend this shape in like one specific quadrant. Yeah, in one specific direction. However, if you draw a center rectangle, you can define the center point, and after that, this rectangle can expand or extend evenly into all 4 quadrants, so that in other words, it's actually symmetrical about the front as well as right plane. Yeah, so front and right plane can be used as a plane of symmetry subsequently. Yeah, this is just my personal habit. Yeah, of course you can have like you can have your own decision based on the situation needed. So after that, here there should be an semicircle that is tangential to this edge, so that the overall shape can be a door shape. So let's draw this semicircle. While drawing the semicircle, you notice that there is a yellow dot in the middle of this vertical line. So this is the center point automatically recognized by SolidWorks. If you click here, and you realize that the center point or midpoint constraint are already like automatically added. So yeah, you can see this is the midpoint relationship has been automatically added. So this kind of like save a lot of trouble for us. Yeah. The next step, we use trim entity to remove this extra line. Then after that, we know that these lines should be tangential. Yeah, it's just one of the way to do it. Of course, in this case, because we know that this arc is going to be tangential, so you can directly use the line function which I introduced in which I have already introduced in the previous video. Move your cursor back, and after that extend again. You will form a tangential curve. You will form a tangential arc. It is also possible to directly use the tangential arc function, which is can be accessed over here. Instead of this center point arc, you choose tangent arc. Yeah, the logic is exactly the same as just now. So this tangent function will be automatically added on both ends. Next, we define the dimensions. So this is A and this is B. So this will be A and this will be B. This is not the end yet. We are still missing this portion over here. This is actually a slot. So to draw this slot, we can access it from this icon over here. It's called straight slot. So basically, to draw a slot is first you need to draw a line. It can be any line. Then after that, the slot will expand outwards like this. Basically, a slot is made up with two equidistant straight lines as well as two semicircular arcs. Semicircular arcs that is tangential to the straight line. So in this case, we draw this arc. Sorry, we draw this slot. We want this slot to be in the middle, so we can define a construction line as the midpoint line. Then we make these two lines collinear so that this arc will always lie in the middle. Sorry, this slot will always lie in the middle. Next, we define the dimension of this slot. The width across it is 14. So this is 14. Then after that, we know that, okay, this is 20. We already defined it. This is quite self-explanatory because we just made it. We just made it lies in the middle, so that since b equals to 40, this distance should equals to 20. Yeah. In this case, because just nice is lies in the middle, so we can use the midline constraint. But in the actual exam, since it explicitly asks for this dimension of 20, so it can mean that if we use different values of b, for example, instead of 40, b equals to 50, let's say, and this 20 dimension will not change. So like in other words, if we use different value for b, this slot might not be always lying in the middle. Yeah, but this is not really relevant in this question. Yeah, so we can still use the midline approach just now, but it's also we can also define this distance as 20, just like what indicated in the question. Then lastly, we know that this point, which is the end of the straight line, as well as the origin or center point of one of the semicircle to the edge is 12. So from here to here is 12. Wait, did I accidentally type 1? Okay, 12. Okay, if you want to change the dimension, all you need to do is under Smart Dimension, move your cursor to the number, then double click your left mouse button, and you'll see this pop up. Then key in 12, then press OK. What else? Let me see. Yeah, this width is 14, and the length of the straight line is also 14. So this is also 14. So we can see that this sketch is fully defined. Ctrl 7 to go to isometric view. Then we extrude it for a distance of C. So to extrude something, to add features to the sketch, we usually single click on the sketch to highlight the whole thing. Then after that, click on extrude. And in this case, we use global variable C. Global variable C. Press OK. And this is completed. Then we need to add this cone shaped portion. So we know that the bottom circle, is shares the same parameter as the bottom semicircular arc, and the top circle has a diameter of 26. So we can actually use revolve to help us create this feature. In this case, we want to create it at the mid plane. In this case, this is the front plane, which is the middle plane, as well as the plane of symmetry. This is also the reason why I created the rectangle just now using center point rectangle. Yeah, because this front plane will automatically become the plane of symmetry. So we create a sketch on this plane. So we can draw out this shape first. Yeah, this is the so-called one of the circular cross section. The circular cross section of this cone shape. Yeah. So we know that the bottom circle has the same diameter as this arc. So in other words, this line should be collinear with this edge. It's also possible to just manually define this as 20. Since this is the radius, sorry. Yeah, correct. Since this is the radius of this circle, we can define this as 20. Then after that, we know that the top is 26. So this will be 26. Do know that the 26 is a full circle. In this case, we are only drawing half of it. So instead of 26, we need to use half of it, which is 13. Then the height will be 15, 15. Next step, we can revolve this sketch about this line. And the last step, we use extrude cut to create this hole. This hole has diameter of 16. 16 has diameter of 16. And we know that this hole as well as this circular edge as well as the bottom one, all these shares the same center point. So we can set a relationship as concentric. Then after that, extrude cut. Like what I mentioned in the like what I mentioned in the start of this video, this is not a true hole, means this hole will not penetrate through the whole thing, you only reach this surface. So we can use up to surface and select this surface. Then press OK. And we get the correct volume. Over here is given that the material is cast alloy steel. So under material we need to specify it. Steel is cast alloy steel. Apply. Close it. Mass property. 229.46 gram. Yeah, which is the correct answer. Before I end, I wish to introduce another method, because just now what we did is we revolve cut a solid body like this, then after that we dig a hole through it. But it's possible to it's possible to finish the process in one step. Yeah, because this hole is also a circle. This hole is also a circle. So in other words, this hollow cylinder can also be revolved, can also be created using the revolve function. So we will restart the sketch. Do the sketch on the front plane. Roughly sketch out the shape first. Make sure it's a closed sketch. We know that we are going to revolve along this axis, which is right at the center point of this arc. So for the first step is we manually define a reference axis using the construction line. Then we put it at the center. It's also possible to define the dimension as 20. Yeah, both works the same way. Then after that, we can define the dimension of this shape. Then after that, we will let this sketch revolve around this vertical dotted line, which is the axis of revolution. We know that this portion will become the solid part. This portion will become the solid part to revolve. Yeah, which will create a solid body. And this portion, which is like not part of the sketch, this portion will also get revolved, but instead of revolving into a solid body, this will actually revolve into a hollow cylinder, which is the hole we just created. Yeah. So let's define some of the dimensions. So for the top is 26. So from this point to the center axis, there is half of 26, which is 13. But it's also it's possible if you have a axis of symmetry, it's possible to directly define 26. So just move your mouse cursor to the right, and you can see that you will automatically multiply and like duplicate the dimension. Yeah. So this is 26, and the bottom is still the same. We know that this hole has diameter of 16. So same as just now, we define this distance as 16. Then the height is 15. The height is 15. Then after that, when we revolve this body, we can see that this is what we get. So if we want to visualize this, so this actually we are revolving this sketch along this vertical axis. So while this revolution is taking place, this hollow this hollow cylinder, which is the hole, has also been created. Yeah, so we just revolve for 360 degrees, which is one full round, and click OK. And we can see that we got the identical result as just now. Okay, that's all for this video.